Good afternoon, welcome to my laboratory. Okay, I have the whole setup running now. You can see that I've just taken the drive coil and tie wrapped it to one of the support posts. It just happens to be in the right place. The thing is turning, the LED is illuminating, but there's a problem, and that's that the LED has to flash once every revolution, not once every magnet pulse, in order to properly freeze the motion of the rotor. So in order to do that, I put in a 4017 decade counter chip in a divide, divide count 4. Put out an output of 1/4 the pulse count that is coming out of here. So that's a divide by 4 configuration, and I got that all right. As you can see, the bottom trace there is the output of the 4017, and the top trace is the drain signal driving the coil. So I now have one output pulse for every 4 input pulses, but the output pulse of the 4017 is the same width as the total period of the input pulse, and that's just too broad. The LED stays on for too long to properly freeze the rotor disc. Even though it's flashing at the correct time and the correct interval, it's just on for too long. The rotor moves too much during the time that the LED is flashing, is on. There's a little camera aliasing there where it shows up every once in a while. So what I've done is I've taken the output of the 4017 and put it up into my DP101, which allows me to control the output pulse width. And then the output pulse width is actually what's driving the LED right now. So now I can take the pulse width control on the DP101 and use that to control the pulse width of that output pulse, like this. Okay, still happening every four input pulses, but instead of being the natural output width from the 4017, I can narrow that pulse width by the DP101. I'm using the 4017 to trigger the DP101, and then single pulse mode out from the DP101 with pulse width control. So now watch what happens to the light as I narrow. That's the wide pulse width. Now I'm narrowing and narrowing and narrowing. There you go. Right there with the really, really narrow pulse width, you can see what you're supposed to see, which is 3 stripes of tape on the disc. Right? You're seeing those 3 stripes right there. I lost all my speed now. There we go. Okay, so with a narrow enough pulse width on the LED, you get the proper strobe effect. Now, if I go to the control on the op amp and I vary that setting, you can see what it does. Oh. It moves. Now we're looking at the 4 one. It moves that dwell point back and forth as I rotate this pot just a little bit. And the reason that it sometimes shows 3 and 4 and 2 and 1 is because the 4017 is resetting at these really, really small pulse widths. There it's showing the 4. So it starts and then counts 4. So of course, whichever pulse it starts with is going to determine where it freezes. Okay, so what have I done here? I've tuned it so much that it's not working anymore. There we go. Got to stay in the range where the thing actually works, I guess. Alright, now that blinking on and off there is the camera aliasing. To my eye, the thing is steady, showing 3. Okay, so what kind of a pulse width does that require? Let me get the oscilloscope a little bit better. Sorry about the flickering, but that's the pulse width right there. You can see how narrow that is compared to the whole pulse. Let's see. There you go. There's 2 of them. 1, 2. So you need a really, really narrow pulse in order to actually get the strobe effect freezing of the disc. All right. And once again, now we're seeing 2 because the 4017 started counting on the second, the second magnet, I guess. All right, you really, really, really need a narrow pulse in order to get a strobe effect. Thank you for watching.